In this video, we are going to look at Introduction to Organic Chemistry. Whenever you hear the word organic, you have to relate it to carbon. Whenever something is considered organic, just know there is carbon in it. So organic chemistry is going to basically be the study of carbon and its compounds. Carbon and its compounds, it's all we are going to see under organic chemistry. So if you hear organic foods, just know that those foods contain carbon. Basically, organic things are considered natural because all natural things contain carbon in them. Because when you look at plants, they get carbon dioxide, incorporate it into their food, and then other organisms can take the food from the plants. So basically, all organisms, all living things contain carbon. That's why most living things are considered organic. So under this topic, we are going to look at carbon and its compounds. So when you look at organic chemistry, we are going to see how carbon connects with other elements to form other compounds. However, in the compounds of carbon, we are going to eliminate some compounds and we shall not put them under organic chemistry. What are some of these compounds? So the exceptions include the following. So the following are not part of organic compounds. For example, the oxides of carbon. We all know oxides are basically compounds that contain oxygen and one other element. So oxides of carbon are not part of organic chemistry, and these ones will basically be carbon monoxide and carbon dioxide. At least we know carbon monoxide is a poisonous gas, while carbon dioxide is the gas that will turn lime water milky. The second class of compounds that we shall not consider under organic chemistry will be the hydrocarbons or the hydrogen carbonates, and the carbonates themselves. So probably you might have calcium hydrogen carbonate or magnesium carbonate. These kind of compounds will not be considered under organic chemistry. So you might find them in some other branches. So it might be ammonium hydrogen carbonate, potassium carbonate, and so on. So with the exceptions of the oxides of carbon and then the hydrogen carbonates, all other compounds that we might look at will be considered under organic chemistry. But keep in mind, whenever you hear organic chemistry or something is said organic, just know it contains carbon in it. So we are going to look at carbon, and then we shall see how we can break it down and identify how we can start looking at the compounds of carbon, or how carbon will behave in its properties so that it can form these compounds. So what makes carbon unique? Uniqueness of carbon. Uniqueness of carbon. So at least we all know carbon. That's very common in living things, as we have just seen. However, carbon as an element in the periodic table, carbon has atomic number 6. So we have atomic number of carbon. When you look at it, it is 6, meaning the electronic configuration of carbon will be 2, 4, or you can also write it as 2 to 4. So when you look at this atomic number 6 giving us electronic configuration of 4, we shall realize that carbon has 4 electrons in the outermost energy level. These 4 electrons in the outermost energy level. And for carbon to bond with other atoms, for example non-metals, it will have to have 8 electrons in the outermost energy level. Let's take a look at when carbon combines with hydrogen. So if you have carbon and hydrogen, we shall realize that carbon, being a non-metal just like hydrogen, they will form a compound of this formula that we shall see in future when we look at what we call alkanes. However, when you look at the outermost energy level of carbon, this is a sketch of the outermost energy level of carbon. We shall realize that carbon has 4 electrons, as the electronic configuration suggests, these 4 electrons. So we shall have our 4 electrons. We want to see how this structure of carbon with hydrogen will look like if at all carbon is bonded to hydrogen. But one thing you'll have to realize, the hydrogen and carbon will have to share electrons. So these other circles are for the hydrogen atoms. As you can see, we need 4 hydrogen atoms. We need 4 hydrogen atoms. That's the third and then the fourth. So remember, hydrogen is the first element in the periodic table, and each atom of hydrogen must have at least 1 electron. Actually, it has 1 electron in the outermost energy level, and I represent it with the blue electrons. So as such, our hydrogen atoms, each of them will be having 2 electrons in the outermost energy level and it will be stable, while our carbon will be having 8 electrons in the outermost energy level, following the octet rule. So it will also be stable. So this one will follow the octet rule of having 8 electrons in the outermost energy level, while our hydrogen will follow the doublet rule. So what happens is that this structure here, or this very structure, can be represented as carbon in the center and then the 4 hydrogen atoms covalently bonded to hydrogen by a single bond. One thing to know when we shall be looking at this organic chemistry is that the covalent bond is usually represented by a dash. So this is the covalent bond. So here we have a single covalent bond. So one thing you should note before we continue is that in organic chemistry, this dash will always be representing a single covalent bond, and you realize that carbon will have to bond to 4 other atoms for it to be stable. So let us look at the actual uniqueness of carbon. So when you look at the uniqueness of carbon, carbon has the ability to form chains. That is to say, each carbon atom has the ability to join with other carbon atoms. So the carbon atoms can join with other carbon atoms. Join with other carbon atoms. So this is the uniqueness of carbon, the ability to form chains by carbon atoms joining with one another through covalent bonds. So take an example of these 3 cases we are going to see. So the ability of carbon to form these chains or to join together to form long chains is known as catenation. So this ability of carbon to join with other carbon atoms, so this is carbon atom, carbon atom, carbon atom. So this ability of joining together is what we call catenation, and with this ability carbon can form different chains. So first of all, carbon can form straight chains. As the name suggests, the chains are straight, or they're in line form. Carbon can form straight chains, as we can see in this structure here. We shall understand this structure later on, but one thing you should note is that it is straight. So we have 4 carbon atoms with hydrogen atoms. We shall later learn which compound this is, but at least if you are to look at this chain, you realize that we have 4 carbon atoms that are in line. This is 1, 2, 3, 4. So carbon has this ability of joining together to form a chain, and in each of these you realize that carbon will be having 4 bonds. For example, this is 1, this is 2, this is 3, and then this is 4. These are the 4 bonds. So each carbon atom will be having 4 bonds. Carbon also has the ability to form branched chains. However, we shall mainly emphasize our straight chains under this course. We have branched chains. So branched chains, just like the straight chains, the only difference is that here we shall have some branches. For example, I might have carbon 1, carbon 2, carbon 3 with our hydrogen atoms. We shall see later on why we are sticking to hydrogen. And then here we have the branch. Let me choose a different color. So when you look at carbon here, this other carbon atom is a branch from the main carbon atom. So this one here is like a branch from this other carbon chain. So carbon can also form this kind of arrangement. And lastly, carbon can form another type of arrangement that we call the ring form, just like in benzene. So carbon can form the ring form. It can form a ring when bonding together. You can have carbon in this format. Obviously here the hydrogen atoms, we shall not draw them, but they are also present. So carbon can form such something circular like this. So this is also a form of catenation, whereby carbon will join with other carbon atoms. For example, A joins with B, B joins with C. So this kind of arrangement is also common with carbon. This is one of the uniqueness of carbon that will help it to form many other compounds, because it can join with other carbon atoms. So let's look at one of the simplest kinds of types of compounds found in organic chemistry. These compounds are commonly known as the hydrocarbons. So we have hydrocarbons. What are hydrocarbons? As the name suggests, the word hydrocarbons comes from 2 words. We have hydrogen. Hydro comes from hydrogen, while carbon, obviously it's carbon. So this is hydrogen, capital H, while here we have our carbon. So this group of compounds found in organic chemistry will be dealing with carbon and hydrogen. So hydrocarbons are compounds that contain carbon and hydrogen atoms only. And our main emphasis under this organic chemistry will be dealing with carbon and hydrogen. That's why in my previous slide or presentation we have seen carbon and hydrogen alone. We have not seen any other element. So when you look at hydrocarbons, hydrocarbons have what we call a general formula. A general formula is a formula that you can use to be able to identify this hydrocarbon or a certain compound to be a hydrocarbon. So because hydrocarbons contain carbon and hydrogen only, our general formula will also contain carbon and hydrogen. So we shall have C with a subscript Cn, and then we shall have our hydrogen, and lastly the hydrogen atoms will also have a certain configuration that we shall use. Maybe, okay, let us use Y and here X, CX HY. So it has a general formula CX HY. However, in this case our X and Y must be whole numbers. Whole numbers. That means X and Y can be 1, 2, 3, 4, if that's what whole numbers means. So all hydrocarbons will have that general formula CXHY. For example, take a look at this simplest hydrocarbon, methane, CH4. CH4 will mean that we have an invisible one here, and that means our X in CH4, X will be 1 and our Y will be 4. We can also have something like C2H4, and that means our X in this case will be this 2 and our Y will be this 4. So this is the general formula for all hydrocarbons, CXHY, where X and Y are subscripts and they are whole numbers. So let us look at the general or the common classes of hydrocarbons. Hydrocarbons are classified into very many classes. However, under this course we are going to look at mainly 3 types of hydrocarbons, or 3 classes of hydrocarbons. Classes of hydrocarbons. So these classes, just like you hear the word class, usually classes have something in common, and in this case we shall be having the following. We shall start with the alkanes. So we have alkanes. We also have alkenes, and lastly we have alkynes. So what makes them classes is that compounds under alkanes have certain physical properties that are similar and certain chemical properties that are similar to them. The same applies to alkenes and alkynes. That's why we call them classes. Just like students in maybe senior 1 may be of the same age group, and then students in senior 2 may also be of the same age group. So classes of hydrocarbons will basically be alkanes, alkenes, and alkynes. In our next video, we shall look at alkanes and see what makes alkanes, how can we name them, how can we draw their structures. Yes, thank you for watching. See you next time.